So this is just me using the second point Q instead of P. So 4 by 2 is 8 minus 16 plus C. 0 going to give me 8 minus 16 is minus 8 plus C, and therefore 8 is equal to C. So, well, C is equal to 8. So it doesn't really matter which point you use because both points lie on the curve. So you're supposed to get the same value for C, right? So this is the equation that I'm working with, the equation of the curve, minus x squared plus 2x plus 8. That is what I'm going to use, substitute into this formula right here to get the area. F of x, remember it's always the equation of the curve, so in this case it's the minus x squared plus 2x plus 8. But you might be wondering, okay, so if this is the equation of the curve, so this is my f of x, what exactly is the upper limit and the lower limit? Well, remember, so like I said, this is not this curve. This curve would actually be looking like this since it's a negative. But anyways, this is just to help you understand it. This curve is the easiest one, right? So let's pretend this is what my curve looks like. Remember, the boundaries are always parallel to the y-axis. This is my y-axis. So boundaries always parallel to the y-axis. And the values I'm looking at are x values. The values I'm looking at are always the x values. So this line is x is equal to something. This one is x is equal to something. So what does that mean for me then? You see these x values, the x values of the coordinates are the my upper and lower limit. So 0 is smaller than 4. So 0 is the lower limit, 4 is the upper limit. That's all that means, right? Looking at the x values, 0 is smaller than 4, so 0 is A, 4 is B. And now I have all the information that I need to find the area. So A is going to be equal to, we said B, my upper limit is going to be 4, and A, my lower limit is 0. F of x, which is the curve, is this minus x squared plus 2x plus 8 dx. And you do what you're supposed to do. You do what we were doing before. Integrate this expression right here, substitute your upper and lower limit, subtract the value, get the value of the area. That's all you have to do, right? So it's simple, really, once you understand what you're doing and when to apply it. So let's integrate this expression right here. Right, if I do that, I'm going to get minus a third x cubed plus x squared plus 8x. Don't forget to put your little bracket thing there. My upper limit is 4, my lower limit is 0. Then I'm just going to substitute my values. So that's minus a third 4 cubed plus 4 squared plus 8 by 4. That's my first bracket. Minus, I substitute my lower limit. So that's minus a third 0 cubed plus 0 squared plus 8 by 0. This right here, this is one of the cases where this entire value is going to be 0, right? And 0 by anything is 0. So minus a third by 0 cubed is 0. 0 squared is 0. 8 by 0 is 0. So this entire value here is 0. What I'm focusing on right now is the value of this bracket. Can anybody tell me what they got? What's the value of this bracket right here? Because this would be 0. Anybody? What's your value? Okay then. Well, 4 cubed is 64. So 64 by minus a bit is going to give me minus 64 on 3. 4 squared is 60. That's a 3. 4 squared on 60. What? 4 squared is 16. So that's plus 16. And then 8 by 4 is 32. And when you put this into a calculator, you should get 80 on 3 unit squared. Well, unit squared. Yeah. You just make sure you put it. Okay. Everybody good with this? Yes? No?
Yes,
Can I move on? Somebody is saying something. Makes sense. Right. Okay, so I'm clearing this, okay? 3, 2, 1. Okay. Let me just do the last one with you. You're required to calculate the area under the curve in the first quadrant. Under the graph, y is equal to 3 sine x. Well, it's different. It is different. Because, yeah, I have my equation of the curve, but what happened to my limit? They didn't give me any coordinates. They didn't tell me specifically what the two x values are. So what am I supposed to do? Well, this is why it's important for you to know your work. Okay? So they required you to pick up that graph. So as the curve y is equal to 3 sine x, you were supposed to recall the sine curve. So this is my Cartesian plane. Let's pretend as a straight line. That's my y-axis. This is my x-axis. They specifically said in the first quadrant. So that means, see this? Let me just take it up. See, this is the first quadrant, second quadrant, third, fourth. They specifically said in the first quadrant. So you see all of this? This does not concern me, okay? I'm looking at this. You were supposed to recall that, what the sine graph looks like. So because there's a 3 here, we know usually the sine graph, if I had y is equal to sine x, the maximum value for the curve is 1, minimum is minus 1. But because there's a 3 here, my maximum is now 3, my minimum is minus 3. And the sine graph looks like this. But even if you didn't know that the maximum value is now 3 and the minimum is now minus 3, you're really just concerned with how the graph looks and these x values here. Because remember, that's what we're trying to find. The x values, we need to know what exactly they're talking about. What are my boundaries? What are the x values that I'm looking at? You're supposed to recall, like if you were doing this exam, that this point here is 0. In radians, the sine graph passes through pi and then it passes through 2 pi. So at this point here, it passes through pi. At this point here, it passes through 2 pi. So this would have been my 90 degrees. This is 180. So 180 is the same as pi. This is 270 down here. This is 360, which is the same as 2 pi. So you were supposed to recall this. That's why I said it's really important. You know, you just finish a topic and you forget about it, or you get in the habit of thinking, okay, I'm doing definite integration. All I need to do is know the rules and, do what I have to do. It's not really like that. Some questions, they like to merge topics. So it's really important for you to understand each topic and all the objectives for the exam. So you don't only know how to apply it, but when to apply it. In this case, trigs came in here because you're supposed to recall what the sine graph looks like. So what exactly are my boundaries, you might be wondering? Well, in this case, your boundary would actually be this 0 right here and the pi to find this area. You needed to recall that. So x is equal to 0 and x is equal to pi. Those are the two boundaries I'm looking at. They said in the first quadrant, right? So you see this little button piece here? Let me use another color. They specifically said first quadrant. So you see this little button piece here? We weren't considering that, right? So when you're trying to find the area, these are the two boundaries they were talking about. Or you could have used like these two boundaries. So I mean, who wants to do that? Just use the 0 and the pi, right? Everybody good with that? These are my boundaries. You good? Yes? No? This question required you to think a little bit.
So miss question.
Mm.
So the boundaries are like the how do I say this? Is the part of like the x-axis that they intersect?
Intersect.
Like they go into basically?
Where the curve intersects?
Basically.
Not necessarily, because the graph that I was showing you before, it looked like this. That curve does not intersect.
Oh, but it lines up with it though.
Okay, yeah, you could say that. Lines up with it.
Oh, that makes sense. Thanks, miss.
No problem. So everybody good? Yes? No? Need me to explain it again? That's fine.
Alright, miss, one more explanation, please.
Like the entire thing?
No, miss, the last part.
What's the last part?
The last part.
But what's the last part?
Like, oh, okay. When you shaded in, like, when you shaded in the things,
This yellow line too.
I guess so.
Anyways, this question specifically said in the first quadrant. The first quadrant is up here, not below this x-axis, up here. This is what I'm concerned with. This, I don't want nothing to do with this, right? So let me just erase it and redraw the curve. We're only interested in the first quadrant. So remember, there is actually supposed to be a curve down here. That's how the sine graph looks. But we're not interested in that because they told me first quadrant, which is above right here. We're trying to find what are my boundaries. So the x values. That's the purpose of me doing this entire graph, right? Well, I said they want me to find the area under the curve. The area under the curve, bounded by the two lines, the two vertical lines, and the curve. So in this case, you have to recall, sine graph looks like this. My boundaries would be this 0 mark right here. So when x is 0 and when x is pi, that's just how the sine graph looks. You need to recall that. And the area that they're referring to is the area right here. It's area under this curve. So the area under the curve bounded by these two lines. And I was saying, you could have used this as well. So instead of using your boundaries as 0 and pi, you could have used 2 pi and this value. What value this will be? This will be 316, and this is 514. Hold on. So yeah, this would have been 514 degrees. Then that's how many? Okay, let's not go through that. Like I said, you could have used 2 pi on whatever this value is, or just use the 0 and the pi, right? So those are your two boundaries, x is equal to 0, x is equal to pi. That's what we're using. Right. So now we have our equation of the curve, we have our boundaries. Therefore, I can now apply this. B f of x dx, f of x is this, upper is always the bigger number, so that's pi, a is 0. What I need to do, p, pi, bigger number, a, 0. Small number, f of x, this, 3 sin x, with respect to x, so you put dx. That's it. Now you apply your rules of definite integration. You know the first thing you need to do is integrate this term right here. So just forgetting the limits for a while. All we're doing is focusing on integrating that expression. So when I integrate 3 sine x, I'm going to get minus 3 cos x. Put your bracket, upper limit pi, lower limit 0. All you need to do now, substitute your values, get the area. So wherever I see x, I'm going to replace it with pi. So that's minus 3 cos of pi. That's my first bracket. Then minus 3 cos. So if I see x, I replace it with 0. 0. What's the value of cos of pi?
Cos of pi,
Mm-hmm.
cos of pi would give you no minus 1,
No.
1.
No.
Hold on a minute. Let me guess every letter of the alphabet.
No. No, don't do that. Remember the proof. This point right here is pi. So if this right here is pi, what's the y value? My x value is pi, so what's the y value for this point right here? If I have a point line on the x-axis, what's the y value?
0.
0. Yeah. 0. So that's my first bracket. Next one, minus cos of 0. Wait, why did I make that graph? Hold on. Let me messing up. That was a sine graph. This is the cos graph. So, what am I saying? I lost my train of thought. What was I gonna say? Right. It's not 0. Can we stop? Yeah, just now. Hold on. Let me just finish this question. The graph that I showed you just now. Okay, let me just erase this too. The graph that I showed you just now was the sine graph, which is incorrect because we're talking about cos, and this is what the cos graph looks like. And if you look at the cos graph and you're trying to read off the value for pi, for the cos graph, it cuts the x-axis at pi and 2. That's the first point, right? And you see this right here. This is pi. And the value for that is -1. So cos of pi is -1. -3 cos of 0. What's cos of 0?
1.
1. 3 minus -3 going to give me 6. Everybody good at that? Yes? No?
Yes, miss. Actually makes sense.
Okay. We're starting.
Yes, miss. I understand.
I'm stopping here because, like, you might fry your brain. That continues. That was a lot. We can't. Oh, okay. Okay. Yeah, I will continue. I will continue. I think you had enough for today. There's one more question, but like, I think I would do it and send a picture. Yeah, I think I would.
No,
do
miss.
it.
I have a better idea, miss.